So we are back to WebAssign for homework because there's no graphing here. So your homework, I think there's 11 questions I assigned. My advice to you is some of these might get a little challenging. Do not wait till Sunday night at 10 o'clock to try to do your homework. You have this afternoon, you're getting out early. Maybe go ahead and try and get it started. So let's go ahead and learn how to combine functions and also find composite functions. So first we're going to practice combining. So basically we're just going to add two functions, subtract them, multiply them, and then divide them. As far as adding, subtracting, multiplying, and dividing, that's the easy part. It starts to get a little bit more challenging when we're asked to find the domain of the combined division. So let's go ahead and try to do these. So the first slide here has adding and subtracting when we're trying to combine the functions. The two separate functions are the f of x function up there in yellow and the g of x. So if you recall from the previous slide, we're going to do f of x plus g of x. So we're going to take the f of x function, we're going to write it down. It's 2x plus 1. And then I'm going to add that to the g of x function. So essentially all we're doing here is combining like terms. So I'm writing the f of x function, which was here, and then my g of x. And now I go back and look for any like terms that I can combine. So there's nothing to add to the x squared, so I'll write that down. Then I'm going to go back. I see I have a 2x plus a 2x, so this will give me plus 4x. And then I can also try to combine my constants. However, when I try to combine those, 1 minus 1 is 0. So my simplified answer of combining f of x with g of x by addition is just x squared plus 4x. Now that I've combined it, now over on number 2, they're actually asking me to plug in or substitute for x the value of 2 into the combined functions. So I already have the answer of f plus g of x, which equals x squared plus 4 of x. I answered that in number 1. So now, instead of leaving the x there, I'm going to plug in a 2 wherever I see it. So 2 squared plus 4 times 2. 2 squared is 4. 4 times 2 is 8. So this answer is 12. So if they weren't combined, if they weren't given like number 1 and then you ask you to answer number 2, you would have to go back and combine them first and then plug in the 2. Now on number 3, we're going to subtract them. So essentially what this means is f of x minus the entire g of x function. So your f of x function again is 2x plus 1. But now I'm subtracting the entire g of x. So either think of this as a negative 1 that you're going to distribute, or just remember or you could do a keep, flip, change. But I'm going to distribute it as a negative 1 or distribute the subtraction sign, however you want to think of it. So 2x plus 1, and then it becomes minus x squared minus 2x plus 1. Now, just like I did above in number 1, I'm going to go back and look for any like terms that I can combine. Nothing to combine with the x squared, so I just put negative x squared. Then when I go to try to combine the x's, 2x minus 2x is nothing, it's gone. So that's out of there. And then now I'll try to combine 1 plus 1, and that gives me plus 2. Notice the next one, it's still using the same functions, and they still had expected me to subtract them. So we just found f minus g of x, and we simplified that to negative x squared plus 2. Now what I'm going to do is take that simplified function, And let me move it so you guys can see it's behind the gallery. And now I'm going to do the same thing, but now I'm plugging in a 2 for x. So negative, and then it's got the 2 in parentheses, plus 2. I'm going to evaluate the exponent first. That becomes a 4. Drop down the negative sign, and then the plus 2. So then negative 4 plus 2 gives me negative 2. So f minus g of 2 is negative 2. Next, we're going to multiply the functions. So for here, the dot in between the f and the g here represents multiplication. Now, you may also see it just side by side without a dot in between. So just remember, when you have two things without a plus sign or a minus sign in between them, it means multiplication. So here, this really means take f of x, times it to the g of x function. So my f of x function was x squared. My g of x is x minus 3. And now I just distribute. So x squared multiplied to the x gives me x cubed. X squared multiplied to the negative 3 is negative 3x squared. And that would be the combined functions. Now for number 6, I've already combined them, so I already know fg of x. So now I'm just going to plug in the 4 into this one, x cubed minus 3x squared. So 4 cubed minus 3 times 4 squared. Again, follow order of operations. Do the exponents first. Now go back and multiply. And then finally subtract. So this answer is 16. So again, remember, this really means get the f of x function and put it on top of the g of x. So my f of x function is the square root of x, and the g of x is 4 minus x squared. And I'm done. So the combining part is the easy part. However, the domain part, this is where it's going to be a bit challenging.
That's all we have to do?
Yep. And then same thing here. If I wanted to find the combined function of number 8, I take the g of x function, put it on the top, and then put the f of x on the bottom. That's the combined functions. However, I need to find the domain. So again, remember the restrictions. You always think that the domain is all real numbers, except when you have a square root and except when you have a fraction. So for the numerator, it's a square root, so the domain of the top is just going to be all values of x that are greater than or equal to 0. And then if you were to write this in interval notation, it would be a bracket with 0 to infinity. The denominator, 4 minus x squared, must be greater than or equal to 0. Or not, sorry, just greater than 0. Because it can't be 0 in the denominator. Now, on the test that you took yesterday, we did not have any x squareds underneath a radical. They were all linear. So now we need to reach back to our knowledge about solving quadratic inequalities. Remember, the first step was to set it equal to 0, because this is the x check thing. So we're going to solve this, and I get 4 equals x squared, square root it, plus and minus 2. So this now gives me how I break apart my number line. And now I have to find a test value to plug in to 4 minus x squared greater than or equal, or just greater than 0. So I'm plugging it back in, my test value, into this. So I'm going to pick 0, which is in the middle here. So 4 minus 0 squared, 4 is greater than 0. This section gets a check, this gets an X, this gets an X. So my domain here for the denominator, the restriction, is going to be values between 2 and -2. So open circles, because it's just the greater than 0. So it would be from -2 to +2. Now, the domain for the composite, now I have to take the numerator and the denominator, put it together because it's the intersection of the two domains, restrictions. So here's my number line, -2, 0, 2. So for the numerator, remember we did this, all numbers greater than or equal to 0. So closed circle going this way, or if you wanted to think of it as a bracket. Then for the denominator, we got this. So it was open circle from here to here, or you could think of them as parentheses. The domain of the combined function, so the domain of f over g of x is going to be the intersection, or where we see green and yellow. So the domain here is going to be bracket at 0 to 2 with the parentheses. So it's only this little section right in here that is the domain of f of x divided by g of x. So it's the intersection of both domains. Let's try the g of x. Or the g of x divided by f of x. So number 8. We already combined it. So now let's go back. So the domain restrictions on the numerator, 4 minus x squared has to be greater than or equal to 0. Again, when it's quadratic, this is where we're doing the x check thing, because it's breaking it into intervals. Square root it, plus and minus 2. Same numbers. The only thing that's switching here now is these are going to be brackets. We're still plugging it into the same thing, but this time now, instead of just greater than 0, it's greater than or equal to. So 4 minus 0 squared, 4 is greater than or equal to 0, so a check x check, or x check x. And again, this would have been brackets or closed circles because it had the greater than or equal to. Now for the denominator, it's just x greater than 0. So this would be a parentheses going to infinity. But again, remember now it's the intersection of the two. So let's put both of these on the same number line. So for this one, it's an open circle going to the right, all greater than. And then for this one, where is it? Over here. This is going to be closed circles. And it's the segment that's joining them because it's 2, 2 with brackets. So then now the intersection of the two is right here. So it goes from the open circle on the 0 to the bracket or the closed circle on the positive 2. I'm sorry?
No.
Oh, there you go. Oops. So now we've combined using addition, subtraction, multiplication, and division. Now we're going to work on composite functions. So basically what we're going to be doing here is taking the whole function, one of them, and plugging it into the other function for x. So notice here in this little notation, it's got a circle in between here. This isn't a dot. It doesn't mean multiplication. This is just a symbol showing that we're going to be forming a composite function. So it sort of looks like it's spelling the word fog. So really what you're going to do is take this g of x function, and this is what gets plugged into the f of x function for the x value. Same thing here. We would take the entire f of x function and we're plugging it into the g of x function for the x value. So let's try to see what this means. So what we're going to do here is we're taking our f of x function and we're going to plug in the g of x for x. Now remember, g of x is this expression over here. So I'm taking my f of x function, and instead of where I see x, I'm going to put in 4 minus x squared. So I'm taking this whole thing, and I'm going to plug it in to my f of x function where I see the x. So if I want to write down my f of x function, it's x plus 2. So now what I'm doing is taking out this and plugging in g of x. So my answer here is going to be 4 minus x squared. So I replaced x with that, and then I'll just rewrite the plus 2. And now I can go back and combine like terms. So 4 plus 2 is 6 minus x squared. Now we're going to go the other way on number 10. So now we're taking the g of x function and plugging in the f of x for x. So essentially what we're doing is taking the g of x and plugging in x plus 2 where I see x in my g of x equation. So remember, your g of x equation is 4 minus x squared. Again, you're taking out only the x, and in its place, you're going to put in x plus 2 instead. So we're going to keep the 4 and the minus. Now what I'm plugging in is x plus 2 for the x, and then I'll put back the square. I now need to simplify this thing. So I am going to FOIL the red, the x plus 2. So 4 minus, and then this becomes x squared plus 4x plus 4. And now I need to distribute the subtraction sign. So this will become 4 minus x squared minus 4x minus 4. Now I'll go back and look for any like terms. So I have a 4 minus 4, which becomes 0. So the final answer here is just negative x squared minus 4x. Now I'm going to take that answer and I'm going to use it in number 11. Because they're asking me to write the composite function for g of f. So now I'm going to take that negative x squared minus 4x, and every place I see x, I'm going to put in a negative 2. And now I'll simplify. Do the exponent first, drop down everything else. Actually, I could multiply the negative 4 and the negative 2, becomes positive 8. And now I'll subtract and get 4. Because it's negative 4 plus 8, signs are different, subtract. So again, what we're doing is taking the f of x function and plugging in g of x for x. So really we're doing f of 4x squared plus 1. So if you want to write the f of x function down, now what we're doing is taking out x and putting this in its place. So 2 times 4x squared plus 1, and then the plus 5. So all I did was take out x and put that in there. Now I'm going to distribute 8x squared plus 2 plus 5. Go back, add the 2 and 5, and you're done. Next one, you're taking the f of x function and plugging it into the g of x. So we're doing g of f of x, or the f of x function is the 2x plus 5. And then if I write down the g of x function, it's the 4x squared plus 1. So again, you're taking only x out and putting this in its place. So 4 times 2x plus 5 squared plus 1. Gonna FOIL the red. The red becomes 4x squared plus 20x plus 25. And then I have the plus 1. So this is just this thing FOILed. Now I have to distribute the 4. So 16x squared plus 80x plus 100 plus 1. And I'm going to add my like terms. 16x squared plus 80x plus 101. And you're done. For number 14, we're going to take the answer we got from number 12 and just plug in -1/2. So we already simplified the f of g. So let me take that. And now I'm going to replace x with -1/2. So 8 and then -1/2 squared. -1/2 squared becomes 1/4. And then 8 times 1/4 is 2. And 7 plus 2 is 9. Now we're going to find the domain of a composite function. So when we find the domain of a composite function, we're going to find the domain of what we get when we simplify it and make it a composite function. But then we have to go back and see if there were any restrictions on the function that you plugged in. So in this case, when it's the f of g of x, we're going to see if there's any restrictions on g of x. If it were this way, we'll find the domain of our composite, but then we have to look for restrictions on the f of x. So let's try it. So first we're going to do what we just did on the previous examples. Let's go ahead and find the composite function. So I'm taking my f of x function and plugging in g of x. So I'm going to take f and plug in 9 minus x squared under the radical. So my f of x function is this. So I'm taking out x and putting this in it. So 9 minus x squared, and that thing was squared because it was an x squared, and then minus 9. Squaring that square root makes it disappear, so this just becomes 9 minus x squared, and then I still have the minus 9. Combine your like terms, so the 9's are going to cancel, and you're left with just negative x squared. Now, there's no radical here, no fraction, there's no restrictions. The domain on the composite is all real numbers. However, we need to go back and check out the domain for the g of x. So the g of x equaled this. It's a radical, so we need to set what's under the radical to be greater than or equal to 0. Once I solve this, I'm going to get 9 equals x squared, square root it. It's quadratic again, so we have to do our checks. So -3 and +3, and I'm going to plug in my test point into this, my test point 0. And it's true, so this gets a check, this gets an x. So the domain for the g of x function is actually bracket and bracket, or closed circle, closed circle. So the domain here is, for the composite and for the g of x function, is -3, 3. So because the g of x function had a restriction, that's the final domain also for the composite. Okay, so here's the last example of the notes. Again, we're still doing the same thing. I'm going to be taking my g of x function and I'm plugging it into the f of x function. So essentially what I'm doing here is taking f of x and I'm plugging in x squared plus 4. So my f of x function is the square root of x. So I'm going to take out x and I'm putting in x squared plus 4. So the answer here is x squared plus 4 under the square root. That is the composite function. So let me go ahead and figure out what the domain is. So my domain for this, it is a radical, so I need to set it to be greater than or equal to 0. And then it's quadratic, so I'm going to make it equal 0. Subtract the 4, x squared equals -4, square root it, and I get x to be plus and minus 2i. I don't care about excluding any imaginary solutions, so the domain of the composite is all real numbers. But remember, you also need to check the g of x function. The g of x function was x squared plus 4. This one is a parabola. There aren't any radicals, there aren't any fractions, so this one has no exclusions. So this is also all real numbers. So the final domain of the composite function is all real numbers. So when your exclusions are imaginary, we don't exclude them in our domain because we're only looking for real solutions. So that is it for the 2.6 notes. Again, your homework is on WebAssign, and look for the problems. There's 11 of them. Have a great weekend. So, all right, so if the original problem was this, then we would check the f of x function because that's what we're plugging in. So it's whatever the second function is, or whatever the function you're plugging in as x, that's the one that you have to check. So the two examples I did, we were plugging in the g of x, and that's why we checked it and not the f of x.
Okay, thank you.
You're welcome.